Welcome to a presentation on real numbers. The goals of this video are to determine the different types of real numbers, compare and order real numbers, and also to determine the absolute value of real numbers. A set is a collection of objects. The set containing A, B, and C is usually written with braces A, B, C. The set of real numbers is made up of all rational and irrational numbers, which we'll define shortly. You can think of the set of real numbers as any number that would appear on the number line. So the real numbers are the numbers that can be written in decimal notation, including those that require an infinite decimal expansion. The set of real numbers includes all integers, positive and negative, all fractions, and all the irrational numbers, those whose decimal expansions never repeat. This tree of real numbers gives you a pretty good idea of the different types of real numbers. So again, real numbers are the set of numbers corresponding to any point on the number line. Here is a variety of examples. All real numbers are either rational or irrational numbers. The definition of an irrational number is the set of all numbers a divided by b, where a and b are integers. But it's probably easier to think of a rational number as a number that in decimal form it either terminates or repeats with a pattern. So for example, all of these, if I put them in decimal form, would either terminate or have a decimal that repeats. So for example, 5/8 is 0.625, it terminates. And if we considered a number like 1/3 in decimal form, this would be 0.333 repeating, so it would also be a rational number. However, if we look at irrational numbers, in decimal form, these neither terminate nor repeat, so they go on forever without a pattern. So if you take the square root of 19, or you look at the digits of pi, it goes on forever, but there's no pattern in the decimal part of the number. Now if we take a look at the set of rational numbers, these can be broken down into integers and then rational numbers that are not integers. So here is the set of integers, and we can see these values fit into this set. And rational numbers that are not integers would consist of fractions and decimals. Integers can be broken down into negative integers and whole numbers. I think negative integers are pretty obvious. Whole numbers start at 0 and increase by 1. So these would be our whole numbers from our original set. And then we can break down whole numbers into 0 and positive integers. The only difference between a positive integer and a whole number is 0 is not considered a positive integer. Sometimes these are called natural numbers or counting numbers. So you may want to pause the video and look at this a little bit closer, but I think organizing it in a tree diagram is very helpful. Okay, let's go ahead and take a look at comparing real numbers using inequality symbols. We have the less than symbol, less than or equal to symbol, greater than or equal to symbol. To compare numbers, it is often useful to convert to decimal notation and or plot on the number line. Smaller numbers are always to the left of larger numbers on the number line. So if we want to compare these two numbers, -3 and -5, and we can't tell just by looking which one is smaller or larger, we could just make a number line and we would see -3 occur somewhere in here and -5 here. Since -5 is to the left of -3, we can say -5 is less than -3, or we can say -3 is greater than -5. Either way, -3 is the larger of the two, so to compare using these two inequality symbols, we would say -3 is greater than -5. Next, comparing 2/5 and 4/7 may be difficult, since we either need to have a common denominator or convert to decimal form. So if we convert 2/5 to decimal form, we need to take 2 and divide by 5, and that would give us 0.4. And if we take 4 and divide by 7, we'll get approximately 0.57. Again, in decimal form, it's easier to see that 4/7 is larger than 2/5. Therefore, we would read this 2/5 is less than 4/7. The same thing with negative square root 8 and negative square root 7. Let's convert those to decimal form. So let's go ahead and use our calculator, and we'll type in negative second x squared 8, close the parentheses, and then we'll also find the decimal value of negative square root 7. So let's go ahead and just plot negative 2.8 and negative 2.6 on the number line. So the question really becomes, which would come first, negative 2.6 or negative 2.8? And it would be negative 2.6, negative 2.8. Again, we know that because negative 2 might be here and negative 3 might be here. Negative 2.8 is closer to negative 3. Therefore, negative 2.6 is larger, and this came from negative square root 7, so we can state that negative square root 8 is less than negative square root 7. And lastly, this one's pretty straightforward. A positive number is always larger than a negative number, so we know that negative 4.6 is less than 5.3. So I highly recommend converting to decimal form and then using the number line to determine which number is less than or greater than the other. Now we have true and false. Negative 3 is less than or equal to negative 3. This would be true because negative 3 is equal to negative 3, and equals is part of this inequality symbol. Therefore, this is true. Next, again, we'll convert this to decimal notation. So we'd have negative 0.75 compared to negative 1. Negative 0.75 is greater than negative 1. So of course it would also be greater than or equal to. Again, this is true. And lastly, 0 is less than negative 3. Again, we can always go back to the number line. Is 0 less than 3? No, because 0 is to the right of negative 3, so this would be false. Okay, let's go ahead and take a look at one more topic. Let's talk about absolute value. When we write A between two vertical bars, this reads the absolute value of A, which represents the number of units or distance that A is from 0. So since distance is always positive, when we find an absolute value, it will always be positive. So when we graph y equals absolute value of x, we can see that all of the points except the point 0, 0 are above the x-axis. Therefore, all the y values are positive or could be 0. So the absolute value of negative 8, how far is negative 8 from 0? It's 8 units from 0. And the absolute value of 7.5 is 7.5. And the absolute value of 0 is 0. So the only thing that I've seen that sometimes causes an issue is if you're asked to evaluate the negative absolute value of a negative number. Remember, you can think of this as a negative or the opposite. So the opposite of the absolute value of negative 3, well, we know this would be positive 3, but the opposite of positive 3 is going to be a negative 3. So there's a negative sign outside of the absolute value that would return a negative value. Okay, I hope you found this video helpful. Thank you for watching and have a good day.